So what are we going to do today? So I'm going to start off with designing a pad, and I've already had a question. This could be considered a way of finding, well, certainly finding the volume of your fill required to make a pad, or cut required if you're cutting into the ground, but it can be used for other purposes. So we'll look at applying this same technique to calculate the volume of a spoil site or waste pit in a road construction area. The great thing about the terrain module is that you can get accurate volumes between surfaces. This is all about, this is what we're talking about today, volumes between surfaces. And if you can make a surface that represents a pad, you can calculate the volume required to create it. But that can apply to all kinds of different things too, like pits, quarries, ponds, stockpiles, and we're going to cover some of that here. I hope to also look at a road volume toward the end if we've got time. Some other applications: campgrounds, bridge sites, culvert excavation and replacement, things like that you can do with the terrain module. Okay, if you've been using our software for a while, you should be aware of our support web page. And let's say I wanted to find out about grading. We have at the top of every page a search item. Type in the word grading, hit the little magnifying glass, and there we are. So, for example, grading a platform is right here. Our web page gives you access to a lot of information, and I'm looking at the web page for the webinars here, and you can see previous webinars. There's a link, and that will take you to a page that shows all the other recorded webinars, and you can view those in YouTube and sometimes in situ in our web page. Okay, well, let's get started with an actual problem. So I am going to open up our terrain module, and first of all, I'm going to take a look at a surface. Now, I'm going to design here a pad over an existing surface. So I could open that surface, and I've got it available here. Let's just go take a look quickly. And that is in this folder here. There we are. So here's the original ground, and it's just a surface. You can see it in 3D if you want. Like so. Now, if I want to create some other construction on top of this, or if you imagine I want to fill up some of this and see how much material I can put in there, I don't start by opening the original ground terrain. I start with an empty terrain. So always when we're working in the grading tool, in the terrain module, we start with an empty terrain, and we put the file of interest that represents usually the original ground in the background. So plan options, background, and just hang on a sec. I'm just going to close my door. Background, add. So here's my original ground terrain. Zoom extents, make sure we can see it. There we are. And this is available for viewing. You can see it in the 3D window, you can see it in the plan window, you can see its elevation, but it's not available for edit. This is just simply a background feature or background terrain. Now I'm going to create the designed pad on top of this. And for our early questioner, this could be the top of your spoil, but I'm going to make a pad. So I need to create a design surface here. I'm going to do the simplest design surface you can do, which is a rectangle. I need to choose an elevation. So let's say we want it to be about this elevation, 1170. So I'm going to create a new feature, and we'll call it pad. It's a 3D modeled feature because it's going to become a surface, and I'll draw that with the mouse. Because it's a 3D modeled surface, it wants to know an elevation, so we'll type one in there. And I'll draw a rectangle. Actually, the simplest way to draw a rectangle is to use this little function here, modify selected feature shape. Of course, that's in the ribbon as well. And I'll make that into a rectangle. There we go. So how big is that? I don't really know what the scale is here. Oopsie. This thing is, created a new feature, 200 meters across. Okay, that's a really big one. Let's make it a little smaller. There. So basically, I can move this thing around. The elevation is a constant because I'm not modifying. It's 1170. I could rotate it. I could do other things too, like, for example, put some more features in the middle to create a drainage surface if I wanted. And I can do that after the fact too. So now I'm going to grade this down to the ground. So again, for our questioner, if you were to put this shape anywhere on your model, it will tell you how much fill will go underneath it. So let's just do that. I'm going to do a grading operation here. Now this feature, let's just figure out which way this feature is going. So it goes it goes clockwise. So if I type the Control N or Control N key, or just go to the next point. There we go, next point. You can see it's moving around. Current point is moving around clockwise, I mean. Right, that just tells me that outside is to the left and inside is to the right. Once I know that, and if I had drawn it by hand, that would have been obvious. Once I know that, then I can go into the terrain modeling grading options and choose left because I want to go outside. I want to grade to what? I'm going to grade, in this case, to the background surface. And we'll look at grading to an elevation in a second. And then I have to choose what my uphill grade is going to look like and what my downhill grade is going to look like. This is usually cut. This is usually fill. So let's change the fill to 2:1. Leave the cut as a 1:1. I need to add some extra points. You'll see where those turn up in a second. I'm going to put one in every 10 meters. Usually you check all of these things because the outside is going to be the outside of my new surface. So it's a tin boundary. We want to calculate a surface. We want to calculate volumes. I don't need contours. Okay. All of this information will be remembered when I come back. Let's see what it looks like. Okay. Now, the first time you do a volume calculation, it assumes that the first surface is the final surface, and this is the original. Well, that's perfect. That's what we want. So we've got mostly fill and a tiny bit of cut. And there we go. You can see the fill shape here, and there's a little bit of cut in this corner here. That's actually cut. Let's look at that in 3D. And there it is. I don't have the background surface displayed. I just have the contours displayed. Therefore, it's guaranteed to be transparent. But terrain actually allows you to display the surface and to set it transparent. Let me just show you that quickly. So if I go into the 3D window options, and I can do it from right click, or I can do it here in the ribbon. There's the background. Currently it's just displaying the features, which are contours. If I choose to display triangles, I probably want to make them transparent, and that's what this alpha channel thing is here. So once again, I did that by turning on the triangles and the shading. That's important too. And then going to the color options and setting the alpha channel. 255 is opaque, 0 is invisible, 100 is transparent, or anything in the range. So there you can see that in this zone here where we're actually cutting, there's a, it's kind of darker because we're looking through the original ground surface to the design surface. Well, you can see that our pad is mostly fill and a little bit of cut, so it's clearly not balanced. How would I balance it? Let's just take the whole thing and lower it down. So I'm going to tile, here we go. There is a tile button in the bottom toolbar, but my window's a little bit small because I'm making a video, so I'm making things, the pixel sizes, or the number of pixels on the screen is a bit reduced, so it couldn't fit that toolbar button down there. So I'm just going up here to tile. Anyway, lots of useful features at the bottom of the screen that are always there. And then the other menu items, of course, depends which one you've selected up here in the ribbon bar. Good. Now I'm going to take this feature, which represents the top of the pad, and change it to elevation. I don't even have to select it by itself. When I did the grading operation, the rectangle which I drew was projected down to the ground with all these features. And these are the ones that are 10 meters apart. I'll show you that 10 meters in a second. And then there's this daylight line here, and that's your boundary feature. It's called SS. It's the tin boundary. So there's no stray triangles out here in this concave area or in here. Right, so let's look at those options again. And, first of all, let's just lower the whole thing down. So you would, I think, intuitively think that you need to select this feature and lower it and then retin it or regrade it. But in fact, you can even have everything selected and then just change the elevation. So change the elevation. I'm used to using this menu here, modify selected features. Shift is a nice one because then you can just say, oh, this is my current elevation. Let's go down a bit, and you type in your new elevation. So I'll do 65. Okay, so I've gone down 5 meters. This is now out of date in the 3D window here. Let's see what the grading does. So back to the grading tool. There's those 10, that's the 10 meter spacing I was showing you. These points here are lines. We call them slope lines. And I don't have to change anything. I just click OK, and it recalculates. It deletes all of those features and recreates them. And now you can see we've got more cut than fill. So I went a little bit too far. We've got a question. Can you have a different elevation on each vertex? And absolutely you can, yes. So for example, if I wanted this whole thing to tilt, easily done. Just got to make sure the current feature, and it is the rectangle itself. I'll just select it by itself so you can see for sure I got that right. There it is, and the name is pad. And I can change the elevation of those points. There's a couple of different ways to do that. I'm just going to use the simplest one. I'm going to go into, this time I will use the ribbon feature tools. And there's a speed key for this, Control R, which does coordinate, coordinates, there it is. So there's 5 points because it's a rectangle that closes on itself, so the first two are the same. So let's make it easy on ourselves and model or modify, say, these two. Okay, so I'll just change that to, I'll raise it up a bit, see if we can make it more balanced. The whole thing's going to tilt now. Let's change it to 68 and update list, and this one too to 68. Okay. You may have noticed a little movement over here. Everything did update and showed that I raised the far edge. Now let's just redo that grading. So back to the terrain modeling, grading, rerun it. And now you can see the volumes are a little closer. My cut is now a little bit less than my fill. And of course, if you've got some expansion or compaction going on, you need to modify these numbers to accommodate that. Yeah, so we just tilted the whole thing. I can move it, I can rotate it, and I don't have to worry too much. Let's just rotate it a little bit to illustrate. I typed Control M to get into move size mode. If I go in here, I can move. If I go over to a handle, I can size. And if I go toward the edges, you get the little curvy mouse, which allows me to rotate. There we go. So I just rotated it. And you can see that now my slope lines and all those other features that were created from the grading operation are completely out of whack. But as soon as I regrade, they get deleted and they get recreated. Now the cut and fill volumes are different. You would expect that. One more thing I wanted to do was to create a little pile. This is really just the same process, but sometimes it's nice to just create a windrow. This is, again, what do you do with your spoil material? So let's say I wanted to put a windrow along the end here. Maybe we stripped off some volumes, some surface material like topsoil and stuff. What if I want to put that over here? Well, here's a way to do it. First of all, let's get some elevations. That's going to be roughly 1170, and over here is 1173. Okay, let me raise that down. And now I'm going to create a new feature. Let's call it pile. Again, it has to be a 3D feature. By the way, I could do this in a completely new terrain. When you make multiple grading objects in the same terrain, you have to be careful to use the surface volume boundary thing. You'll see in a second. Okay, I'm going to put it in the same terrain. It's going to be drawn with the mouse, and the first elevation is 1170. It's down here somewhere, and this elevation up here, I need to actually set it. And I'm going to set it to, whoops, I actually should have made this thing higher than the ground. But let's start with 1173, and then I'll just lift it up a bit. Oops, I typed the wrong thing. I didn't want that. Delete. Okay. There we go. Now you can grade a line, but it doesn't grade off the ends very well. So I'm just going to buffer it quickly. And again, that's all in my Featured Tools ribbon if I'm so desire. Let's make the top of the pile, I'll just make it really nice and small. So what have I done here? I've moved, there. I've created a little polygon. So I don't need this anymore. This is now at the top of my pile. And I want that to be one polygon, Control J join. Again, those are all in your feature tools. There's join. And I want this to be above the ground, so let's raise it up 5 meters. Here's the other way to raise, there's the shift function. The other way to raise it is to do a coordinate transformation, which I don't see in here. There it is, yeah. So I could say we're going to go up. We're going to go up by 5 meters. Okay. And now you'll see if you look at the elevations that it has indeed changed. Great. So I've got the top of my windrow pile sitting here. Let's just grade it out, see what it looks like. So back to terrain modeling grading. Let's grade down to the original ground. And I've forgotten which way is left and right, so let's just assume that left is correct. If you get it wrong, you just come back here and fix it. So I'm grading down to the original ground, and my negative slopes will make 2 to 1. Again, I'll put in a 10-meter thing here, 10-meter spacing for slope lines. And this is, yep, that's already correct. Good, let's see what happens. Yeah, I'm pretty sure I went the right way. But before we look at these volumes, let's look at the, oh yeah, I think we've got no surface here, we've got a surface over here. So let's just make sure everything's correct. This one should be a surface volume boundary and a tin boundary, correct? And so should this one, tin boundary, surface volume boundary. Okay, and now let's just recalculate the surface. That's better. So now we've got two disjoint surfaces, and if we look at the volumes, it all gives me one big volume. That's not very useful. Here's where you can fix things. You put in this checkbox here that will take each of these surface volume boundary polygons and calculate them separately. Okay. So why am I only getting SS1? That's a good reason, good question. I think this one, no, surface volume boundary, that's correct. And this one, apply. There we go. Now these are both called SS1, so it's a little bit confusing. I can rename that if I want, but if that kind of messes things up if you do a regrading operation. So just be aware that this one is called SS-1, and this one is called SS-0. So the first one we created has a 0 index on the end. Right, volumes again, by polygon. There we go. So my pile, which is the -1 boundary, of course is all fill. And my other one has some cut, some fill. And just like for the pad, I could change the elevation of this feature here, and that would, of course, raise and lower the volume. So this little pile that you can see in the 3D window is 5,000 cubic meters. Okay, any questions about that? These are the basic tools that you use for a lot of different projects. I mean, here I've made a pad. It could be, in this case, we're looking to see what shape we're going to get if we piled 5,000 cubic meters. That's what it would look like. I mean, obviously, I can change the location of the top of the pile and get different volumes. And here's my pad. But there's lots of different applications for this. So let's take a look at a couple of applications. I want to show you a quarry. So let's open a completely different surface here and put a quarry in it. Okay, I'm just going to save this in case I want to come back to it. So let's call it demo. Like most grading operations, we don't start by opening the original ground. We start with an empty terrain, and we put the original ground in the background. So plan options, background, add. And in this case, I want to go to this folder here and open this one. Okay. And again, you always need to do a zoom extents after you put something in the background. If you have foreground features, you're going to see them. It automatically goes to the extents of the foreground features when you add them or insert them. But with the background terrain, you need to do a zoom extents. Okay, there we go. So I've got an original ground here, and I'd like to make up a pit. I'm going to cut into the bank and remove some material. So this, instead of drawing the top, I'm going to draw the bottom. So I'll just do that quickly. Draw a feature. Oops, I clicked on draw feature instead of new feature. That's fine. Let's see we got the right thing. We want elevations checked here, and we want it to be called pit bottom. Sorry about that. Okay, and I'll apply that, and then I'll draw it. Okay, so here's the pit bottom. Now, that elevation needs to be changed right away. We've got elevation 1170, and the elevation of the surface is 1252. So let's just change that elevation. Actually, you know what? I'm just going to start again. I'm going to push the right button, push the new feature button. Let's call it pit bottom. And it's an elevation feature. And we know that we want it to be at about 1150, so that's what I'll type in there. No, 12. I forgot. 1250. Okay, pit bottom. That's the elevation of this flat area here. And then I'll just push that elevation back into the bank. You know, I always close my polygons before I grade them. I don't even know what happens if you don't. Sometimes our software works nicely with an open polygon, but I like to close it just to make sure it looks right and that there's no glitches. Okay, so now I'm going to grade that up to the ground. Again, you need to define a cut and fill, and because I drew this in a clockwise direction, left is outward. Same stuff here. Maybe I'll make this a little finer this time. And in a new file, often the contours are turned on, so I don't need contours for this. Okay, let's see what that looks like. There we go. And again, the 3D window is great for visualizing what you've done. You can see quite clearly what's going on here. It's cut into the bank, it's removed a bunch of material, and it showed me the volume, but I closed that really quick. Let's just go back to display volumes, and original, that's all correct. And so there's lots of cut. Oh, lots of fill too. What's going on here? I wonder if it remembered those from before. Oh, that's what I have. Yeah, okay. It remembered this checkbox. I'm going to turn that off. There we go. All cut, no fill. That's what I expected, because I'm actually a tiny bit below the surface, even on the entranceway here. And of course, any changes you make, you can instantly recalculate, and it will update everything in a blink. So lower volume, different shape pit, and so on. Okay, well, we've pretty much finished our half hour. I'm going to show you quickly an output pile, and then, or an output, actually it's for a pad, not for a pile. And then if you want to stick around, I have I wanted to show you how to calculate the volume of a surveyed pile, a stockpile. So first of all, let's look at output. So if I create this pair of terrains, I can draw a line through here and look at cross sections. And I'll just do that quickly. So if I create a brand new feature, which is a draped feature like so, and I draw it across my new pit, it's falling off the model here, but only the foreground pit. It's actually going to get draped on the background too. Anyway, I don't need to see this warning a second time. So there's a cross section, and you can see how it falls off the pit in the 3D window. That's what those two pink lines going down are. And now let's just look at that in 3D. So I'm going to open, not 3D, profile. Let's look at a cross section. There it is. You can see it automatically picks up the background surface and the foreground surface, so you can see what the section looks like at that point in the plan window. And I can move that around too, or add another one, and it updates while I do that. So here, starting on the flat plateau, going, here we go, up into the top of pit. Okay, if I did a lot of fiddling around, I could also make for you a multi-plot. And rather than do that while you're watching, I'm just going to cheat and open one up that I have already. And it is in this folder here. Okay, let me. So in this design, we created a pad. Do I want to save this? Sure. Quarry 2. In this design, we created a pad, and you can see that the there's an area. Well, these lines in the center of the pad have different elevations from the boundary. So we've actually got sloping edges here, and then a flat surface in the middle. And you can see that in the cross section. So I've created these 3 blue cross sections. Notice that as I move in the cross section window, I get a cursor in the plan. So it's easy to see which one is which. And that's great. I've created the pad. I got all my cross sections. Now in the next design, oh, we're not in the right folder. How the heck did that happen? Oh, well. This one, I've actually gone to the trouble of making a multi-plot. Let's just set up the page size. This is I'm going to print this to PDF. PDF is great because then you can have all kinds of different sizes of paper. Landscape, okay, there we go. So obviously I chose the wrong page size. Let me try that one more time. Statement, huh. I thought statement was the same as tabloid, but apparently it's not. Okay, so this is an example of a multi-plot inside the terrain module. Unlike location, you can only do one page at a time, but here we have a plan, 3 cross sections, a bunch of title block information. In the background of the plan, I've got a cut fill map where the cut depth is proportional to the color. I'm not going to show you how to make that here, but that's another thing you can do with terrain. You would use the export to grid function to do that and subtract 2 surfaces. That's all I wanted to cover officially, but I will do a couple more things now. I'm not sure whether we'll put these on well, we'll probably put them in the video. You can always stop the video. Anyway, thank you all. But if you want to stick around for another 5 or 10 minutes, I'm going to go over merging a road into an original ground surface and doing road volumes and comparing them. Right, so let's take a look at the location module. That's where you generally design roads. So I'm going to open up a road that I've created, this one. Now this is a very simple road, and you know, the webinar today is all about the terrain module, not the road design module. But a couple of things you need to know about the road design is that when you're working in our location module, you can have expansion compaction factors in your material. You can have stripping, and you can have multiple layers. So actually comparing volumes between location and terrain can be tricky if you don't take those things into account. But here we go. I'm going to export the red line here. That's the original ground, pardon me, that's the subgrade surface. The original ground is in black. Just do that with file save as, to terrain. And I'll call it, again, I'm in the wrong folder, just a second here. Oh no, Bluff Road Metrics, the right folder. Good, yeah, okay. I've already created one, so I'm going to put a 2 on the end of this so I don't step on my existing surface. When you export, if you want to make a surface, you need to choose which surface you're exporting. I'm going to export the subgrade material, and this boundary checkbox is very important to create a surface that is confined to the disturbed area, to the toe, fill, top of cut. You can add linear features if you want. I'm not going to bother. Okay, and there it is. So this, let's just look at that in 3D while we're at it. There we go. So there's the designed surface. Now that's just another surface, so that means I should be able to do volumes and stuff. Okay, so let's add in the background here, let's add the original ground. Okay, Bluff Road Metric, there we are, and I was using this one, right? Okay, there we are. And now I can subtract those two and calculate the volume that the road used. Okay, so go to the terrain modeling, calculate volumes. The two surfaces are already there. The background surface I could change if I wanted, but it picks up the first background by default. And okay, and there we go. We got this much fill and that much cut. Is it correct? No, we've got it backwards. There we go. The final is the design surface, and the original is the original ground terrain. Okay, so it's telling us we're cutting 243 cubic meters and filling 2156. Let's just see what that is in location. And no, I didn't turn on the totals here. That was silly. Let's turn on the design totals. There we go. And they're very close. Now, those are close because I was careful in my materials to not have expansion compaction. If I put in a factor here, let's say this material compacts down, so I'll put in 1.2, a 20% compression of the material, and recalculate. And of course, this number changes, and it no longer compares with that number unless you multiply by that factor. What about different station ranges? Turns out that with our volume calculations, you can pick polygons, just like I did with the pile and the pad in the original example. You can make polygons that have a special property that will choose, let's just open this, whoopsie, just open this one, that would allow you to choose where you calculate your volume differences. So this is exactly the same export, except I drew these two polygons in here. And I was careful to choose the, this is station 100 here, and this is station 200 up here. And these polygons have this property, surface volume boundary. Other than that, it doesn't matter. They're not 3D features. They're not part of the terrain or the surface, but they do give me areas of interest. And now, when I calculate volumes, if I turn on that volumes by polygon, it gives me two different volumes by station range. And if we go back to location, I better just change that ground type back to 1 expansion factor. You can see that from 0 to 100, 244 cut, 137 fill. And when we do it using subtraction of surfaces, we get roughly the same number. They're never identical. Calculating volumes by average end area, which is what location does, is always going to be a little different from subtracting surfaces. And you can get them to get pretty close to each other by sampling at a reasonable spacing. And yeah, I think I don't need to go into all those details. Okay, the final thing I wanted to show you was how to calculate a stockpile. Oh, I also wanted to show you a merged surface. Okay, so I got a terrain open here. We don't need this one anymore. Let's just close that one down. This is the design surface. This is the original ground. Can I make them into one finished grade surface? Yes, I can. So I'm going to open up the original ground, which is this one. And then there's a merge function here, again in the terrain modeling ribbon, which allows me to put any surface I want in there. So let's just pick this one. No, this one. Okay. Okay. And there it is. One more step. I've got the roadway and the original ground points. The roadway points have removed original ground points that may have been in that zone. So cut a hole and then place the original ground in there. Pardon me, the subgrade, the final ground or final grade. And now I'm going to build that terrain. There we go. And you can see in 3D that we definitely have the finished designed road in that surface. It's quite different from the original ground. Right, and I said I wanted to show you how to calculate a pile. Again, this was supposed to fit into the first half hour, but there we go. So here's a pile. You can see it in 3D. It's a little blob at the end here. How much volume is in that? Well, I don't have the original surface. If I had the original surface before they put the pile there, then I could calculate volumes between two surfaces. But you can also calculate volumes enclosed by a single surface, but you generally need polygons. It depends. I mean, if I had a survey that showed nothing but this pile, I could just calculate the volume using a single surface, and it would give me the approximate volume of the pile. But here, I'm just going to create a polygon around it. I do that with new feature, and I draw it. I'm just going to save some time here and open the existing file that has it in there. So there we go. We've got a polygon drawn around the pile, sitting on what we hope was the original ground before the pile was put there. And that will be an approximate surface for the before, or if you like, the original surface, the pile being the final surface. And now I can calculate that volume. Oh, and I had to make sure that that surface is a surface volume boundary surface. So I checked this thing here, apply. Now, calculate the volume, and a single surface by polygon, okay, and there it is. So that's roughly 738 cubic meters. Right, so that finishes the second half, the late half of my demonstration. Thank you for your patience if you stuck around. And we will be posting this to our YouTube videos section, and you can access that from our webpage or search YouTube.